time in India, and I've loved it. The food's been great. Everyone's been really warm and inviting. I've enjoyed watching my life flash before my eyes during our auto rickshaw ride last night. I've also been told that it's incredibly important to thank everyone. So I've made a list of the 1.252 billion Indian citizens, and I now plan to thank each one individually. So get ready. But seriously, I wanted to talk about some pretty serious issues that I think are plaguing society right now. And I, like many others, believe that we're kind of in this era of increasing crises, that the fundamental underpinnings of our civil society, our very human and civil liberties, are under sustained attack. And whether you look at anything from the division of wealth to our planet's ecological health, or the sustained attacks that are on our rights to privacy and free expression, these assaults are creating ever-increasing harms that are going to haunt us for generations to come. So let me grab my pointer here. With any great maelstrom, there are also unprecedented opportunities to better ourselves and our society. And I think that as productive members of our communities, we actually have a responsibility to act on this. We have a responsibility to use our expertise, to use our abilities to leave the world a better place than when we came in. So with this ethos, I kind of went into the belly of the beast in Washington, D.C., and I have an inherently optimistic outlook on both our current state of affairs, our ability to address them, and hopefully by the end of my talk, I will have many of you convinced that while these issues are very real, and the problems we face quite substantial, they're also entirely surmountable. Now, today I'm going to tell you about the current state of affairs in Washington, D.C. It's depressing, I'll warn you now, spoiler alert. But I'm also going to talk about some of the truly disruptive technologies that I and my team have been quietly developing for the past decade and a half. And I can say that after about $8 million in research and development, I'm pretty confident that this work is going to disrupt dominant business models of some of the largest corporations on the planet. I think it also, though, is going to help inoculate communities against oppression and tyranny. And fundamentally, it has the potential to alter power relationships between people and our governments. And it won't do this with profoundly expensive science fiction-y black box technologies, but with the devices that we already have in our pockets, in our backpacks, in our briefcases. It'll do this with software that is open source and freely available to all. So first I want to take you on a very brief trip through my own history so you can understand sort of where I'm coming from in the work that I do and why I bring a pretty different perspective than the norm. And then I'm going to go into this quick descent into the seedy and nefarious underbelly of Washington, D.C. to give you a glimpse of what I experience every day. So in the 1990s, I was an avid environmentalist. Now this is not a time when everyone was into recycling and environmental work. This is before that. As I've mentioned many a time, I was kind of a dorky kid, and I liked to hike and to camp and to be outdoors and to do things in nature. And wilderness protection led to food politics. And in the late 1990s, I started graduate school in central Illinois. And Urbana, Illinois is nothing but soybean fields and corn fields, and then this university town that's plopped right in the middle of all of that. And there I started working with and eventually helped leading our local food cooperative. And at the time, a bunch of local friends that were involved in Common Ground were also involved in unlicensed radio, pirate radio. And that was my gateway into the world of geeks. Also, by the late 1990s, there was a fundamental change happening in the technologies that were available, right? Digital media production technologies were entering the consumer market for the first time. And this brand new technical standard was also getting set and entering the consumer market. This was an era where 802.11 Wi-Fi was just beginning to enter into the big box technical stores. And in the 2000s, in essence, you had the rise of the use of these technologies. So community radio led to food politics, led to media activism. And in 1999, a small group of individuals, realizing that this upcoming protest in Seattle, Washington, was going to be pretty substantial. It actually ended up becoming one of the largest protests of that era in the United States, worked to create this place where people could use these new digital technologies to document what was happening in the streets on the ground. And think of this as a pre-Arab Spring, a pre-Occupy movement, proofing out of technologies and tactics that people were going to use in coming years. And we created this independent media center in order to house that media production facilities. And that single independent media center grew to hundreds of independent media centers. It grew into something called the Indie Media Movement, which at one point was the largest citizen journalism endeavor initiative on the planet. And I realized that while we were doing a great job of collecting information and doing all this, we had no meaningful way to upload the data that we were collecting. We were taking photos and we were taking digital video and et cetera, but there was no mechanism to get that online other than to go to a physical bricks and mortar space. And thus, in the summer of 2000, I invited a group of super geek friends over for pizza and beer to help solve the problem of how do we create a mechanism to upload in real time the media that we were creating in these spaces. And in my technological naivete, in the summer of 2000, I thought this was going to be a great summer project. Now, what I came to realize after doing this work for several years was that the problems we were facing were not technological. They were very real. We had to create a whole set of new technologies. But the real limiters on what was possible were more political and regulatory and policy. And thus, in 2004, I became much more involved in DC political processes, and specifically around spectrum policy and telecommunications policies. I wanted to create policies that would better enable us to build these kinds of systems so that we could build the kind of communication system that we really wanted to see. And in 2007, I took the plunge. I left my PhD program. Officially, I'm on sabbatical. But I left this program and came to Washington, D.C. as the research director for something called the Wireless Future Program at the New America Foundation. And in the 2000s, I learned a lot about not just technologies, but the way that policymaking actually works. Now, D.C. is a very strange place, a really strange place. It's full of people with incredibly high ideals, strong personalities, but more importantly, a desire to do good in the world. But unfortunately, DC is also this space where ideals and visions first get tempered and then eventually subjugated to political pragmatics, the politics of compromise. In essence, it becomes a very cynical place for many people very quickly. And fundamentally, I think, especially when it comes to tech policy, one of DC's biggest problems is far too many lawyers and far too few geeks. And so this was a problem that I set out to solve by creating something called the Open Technology Institute. And the Open Technology Institute brought together tech-savvy, policy-savvy folks in order to inform key decision-making around issues that were rising between 2008 and today. But the Open Technology Institute was also this tech incubator. It composed of everything from a venture capital fund that invested millions of dollars to create open source circumvention technologies, to a place for building technology itself. And this is epitomized by things like the measurement lab, as mentioned earlier, which today, it does broadband measurement and et cetera, but it grew from an idea to something that we created, actually with a guy named Vint Cerf, who I think many of you may have heard of. But it created what is today the world's largest repository of open broadband data measurement. Right, we're just over, I think, a petabyte of raw data that anyone can use to investigate what's actually happening online. And it's an open platform, so researchers can use this global measurement platform to run their own experiments. That is a huge resource that we created. And it's, to this day, continues to be coordinated out of the Open Technology Institute. And OTI was also this place where I recruited a team that I'd worked with in Illinois. And actually, I think it's Illinois where I first met Pierre Kumar, and we started working together back when we were young, right, on mesh wireless technologies. But this team went on to create what became known as the Commotion Wireless project. And I ran OTI for 6 years, from 2008 until 2014. grown it from this modest idea to a pretty amazing collection of some of the smartest technological, political minds in the country. And when I stepped down, it was a team of about 50 people working inside the belly of the beast. For me, it was this bastion of sanity in an otherwise completely insane political space. And today, OTI holds this line on everything from internet freedom, fighting for our privacy rights, to self-provisioning of community-owned technologies, and et cetera. And after years of fighting on the front lines of these tech policy battles, I realized that I was always reactive to bad decisions, right? People made this decision, and then we jumped in to try to save something or make the decision less bad or fight against the final implementation of that decision. And what I decided was really missing from this space was a vanguard, something looking 3 to 5 years out and working with key decision makers to prevent the bad decisions from getting made in the first place. To me, this seems in many ways obvious, but it doesn't exist right now in Washington, D.C. So with that in mind, I stepped back as the director of OTI and created XLab. Now, let me give you an example of what's wrong in Washington, D.C. today. So since World War II, what we've seen is an ever-decreasing number of laws introduced. Those are the bars. And an ever-decreasing number of introduced laws actually getting passed, which is that blue line. This is pretty scary, right? Under any circumstances, this is a big problem. But when you think about the 20th century, a mechanistic era giving way to an era where change is rapidly increasing, where our laws from the 20th century are in rapid need of improvement and updating, where our laws are often obsolete. They just simply do not map onto technological reality and often are antagonistic to technological reality. This state of affairs has proven to be horrendously bad news for all of us. But that's not actually the worst part, because technologies are integrated into an ever-increasing array of different facets of our lives. These changes are increasingly, in fact exponentially, creating more and more problems. Now, if we assume that politicians are, and probably always will be, 20 years behind the times in their technological knowledge and thinking, and 20 years may be generous, I understand that, but let's say it's just 20 years. When you map this ever-increasing rate of change against this linear rate of understanding, what you see is this ever-widening gulf between rule of law and technological reality that will impact education and health and every other facet of our life. It's what I call this policy-making gulf of ignorance, and it's growing rapidly. And if you want to know how this actually impacts all of your lives right now today, let me give you an example. This is a statement from Senator Dianne Feinstein. Now, she was the chair of the Senate Intelligence Committee, which is responsible for overseeing the NSA. And when asked about some of the revelations that Snowden was making, said this, I'm not a high-tech techie, but I've been told that's not possible. So here you have a global surveillance regime seeking out information on all of you on a daily basis, overseen by people that cannot comprehend how that kind of system can even exist. Now, as this example illustrates, something has clearly broken down. But I actually believe Congress members were telling the truth when they said that they had no idea what the NSA was doing. But I also believe the NSA was telling the truth when it said, we have fully briefed Congress on all of our activities. Right? Because here's how you can see this happening, right? So everyone gets called into a secure room, and the NSA says, okay, we're going to do a secure briefing. Anyone that does not have security clearance needs to leave. And so all the staff, the last possible chance we had for any technological acumen in the room, leave. And the NSA super geeks go and they say, okay, well, look, here's what's going on. And they lay out in highly technical terms exactly what they're doing which Congress members have no comprehension whatsoever of, and they smile and they nod because they don't want to ask questions and demonstrate their ignorance. And in the end, what you have is exactly what transpired. And of course, what we know is only a tiny fraction of what's actually happening. As I like to remind people, two things have never come out in the Snowden revelations. One, pictures, and two, video. So either you believe that the largest intelligence apparatus on the planet isn't interested in pictures and video, or you realize that there's an entire other facet of surveillance and data collection that has never yet seen the light of day, and that should scare all of us. So with this gulf of ignorance as the backdrop, let's take a look at some of the technologies that I and my team have been developing that can actually kind of provide a 21st century upgrade to participatory democracy. And one of the big ones is this Commotion Wireless project. Now let me first say I have a very bold goal, which is free, safe, ubiquitous communications for everyone on the planet. And a lot of people first got to know this work through a front-page New York Times story in 2011. Right? US underwrites internet detour around censors. And the New York Times wanted what they called a sexy picture of our work. And let me tell you, geeks sitting in front of computers programming is not sexy. So we had proposed that we could gather up a bunch of equipment and stick it into a briefcase, and they loved that. So we grabbed a bunch of equipment laying around the office and put it into a Pelican case. And this became known as the internet in a suitcase. And the sad reality is there's not actually any suitcase, but this is the meme that has stuck with the project for the last 3 years. And everyone thinks this is about shadow internet and cloak and dagger and, fighting against oppression, et cetera. And it's true, like that's one of the use cases for Commotion. But it's a tiny fraction of what we're actually doing. So in 2014, the New York Times ran a follow-up story. In 2011, it was looking forward. Here's what they planned to do. And in 2014, it's like, here's what they actually did. And in this case, they focused on a network that we'd built in Ceuta, Tunisia. And I love the way that I don't know if you guys can actually see this, but the way they talk about the work, right? We're a team of American hackers, right? Like everything about this is really focused on making this much more exciting than we've developed a low-cost communications infrastructure for everyone on the planet to build their own systems. Apparently that doesn't sell newspapers like this headline does. But I will say that the work that we've done has impacted a number of communities all around the globe already in providing low-cost communication. I'm going to talk a little bit about how that's possible. So traditional telecom networks use a hub and spoke architecture where every device connects up through that central point. Anyone who's ever used a cell phone knows exactly how these systems work and of course when they don't. And Commotion, on this other hand, uses this distributed system, right? It directly connects people and devices to one another. It's a peer-to-peer architecture that is often faster, certainly cheaper, and often better meets the local needs of communities. And as your phone bill will attest, and as the NSA has clearly taken advantage of, hub and spoke systems are a great way to maximize billable moments. They're a great way to maximize resource extraction from local communities, from your pocketbooks and wallets. But they're extremely expensive or relatively expensive to build, inefficient for local communications in the extreme, right? If we try to send text messages to each other, we can only do so through a cell tower, which is ridiculous, and dangerously problematic, as we've now know for fact when it comes to facilitating censorship, surveillance, monitoring. Now, what we've pioneered are these technologies to create a device as infrastructure network, a web of connectivity where the device is already in our pockets, our cell phones, our laptops, our Wi-Fi devices, and briefcases. They are the infrastructure. They are the network. And as small groups of Commotion devices overlap, they can create larger and larger networks. So with Commotion, anyone can build a 21st century telecommunications infrastructure. And likewise, you can actually integrate it with existing infrastructure. It is a complementary technology. And it doesn't take a genius to realize how this might pose certain opportunities for community as well as serious challenges for antiquated business models, especially ones that don't best meet our needs. Now, like the internet itself, Commotion began with a very simple idea, right? How to connect a few houses in our town together. And we had no idea in the year 2000 whether it was even possible to do this, right? It was an open question. It was a hypothesis that we were testing out. Can you build scalable mesh? And we were just a bunch of curious geeks eating pizza, drinking beer, and writing diagrams like this, but experimenting with this new technology, 802.11. Before 802.11b is when we got started. And we had to build everything from scratch. So if you think about, say, wireless routers today versus what we were doing, which was repurposing old 486 and the first generations of Pentium class computers into Wi-Fi computers. That was one of the ones that we used in our network for about a year and a half. And building our antennas, right? There was no place to go at this point in time to buy outdoor antennas. So the antenna was built out of a Pringles can and sealed up in some PVC piping, and that enabled us to create our first outdoor antennas. And eventually, the refurbished desktop router, thankfully, gave way to this, which we call the ammo can router, where every piece of that had to be hand-built, and it took forever to create one of these things. But this actually ran for about 6 years outside. So pretty rugged, actually, at the time. And the handcrafted ammo can router gave way to the threshold node, and you can see this is now beginning to get smaller and smaller and smaller, which was great, easy to access, but not weatherproof, as we found out. Illinois can have some pretty nasty weather, and as it turns out, your network would go down every time we had that kind of nasty weather. And eventually to this, the metrics node, which is the size of a few stacked CDs. Again, had to be handcrafted in certain elements. I have a little bit of nostalgia for doing this. We had to build a lot of these. You can see in the background there all of these poles that had metric nodes on them. And each of these devices had to be installed by hand on people's roofs. So here I am back 10 years ago climbing around on roofs. And almost dying a few times. We did not really know what we were doing, but that didn't stop us from doing this. And we had some experiences. I got attacked by a squirrel at one point, which almost led to me literally falling off of a roof. And by 2005, we were building networks that spanned dozens of square blocks. So this is downtown Urbana-Champaign. And what we had been told was this kind of scalable mesh was impossible. Not difficult or complex. There were real experts in the world that were telling us it wasn't possible to do. And even after we built that, we were still having arguments online with people saying, you could never build a network of this size. And we were saying, well, we just built it. And they would not believe it. And even to this day, I constantly am hearing people talk about how mesh does not scale. And what we have are the reality proofs that say otherwise. And we weren't alone in these endeavors. In 2004, I hosted the first International Summit for Community Wireless Networks that brought together leaders from programs and projects that were doing this all around the globe, all over the place, in fact. And this wireless summit rapidly became kind of the key convening for people in the community wireless space. And in 2010, kind of in recognition of the work that we were doing and the interconnections that we were fostering between all of these different groups, right? That the development, all being open source, spanning all of these different organizations, had become this global endeavor. The US State Department made a multi-million-dollar investment in this free open source technology. And we branded the initiative the Commotion Wireless Project with the goal, of bringing safer communications to people working in areas of heavy government surveillance and repression. And over the last several years, we've built a number of testbed networks in the US and Asia and Africa and elsewhere. And we've seen additional networks being built by people everywhere from St. Louis to Somaliland using these technologies. We get contacted now once every week by people that are using and experimenting with the Commotion technology. But what's really exciting about Commotion isn't just its ability to share internet connectivity, but its ability to facilitate local communications, even in places where outside connectivity doesn't exist, like, for example, Tahrir Square. So we started looking at how can this technology be used for pop-up networks, and we built 3 of them. You can see the number of devices for the backbone, the number of builders, the number of hours it took to set up. And these networks spanned anywhere from a few hundred users to several thousand users. And as you can see, you can build them pretty fast with the Commotion technology. Now, as this screenshot here shows, you've got your internet connectivity, you've got your local applications, and both of those are crucially important. At the Allied Media Conference, what we put on there were local services that included everything from information sharing, local networking services, local applications that were tailored for that specific installation, i.e. that best met the local needs of people on that Commotion network. And at this Allied Media Conference, we had everything from the conference program, local tweeting, maps, notes from sessions, even streaming video from some of the performances that were happening at that conference so that you could stay in your hotel room and listen to the jazz or what have you that was coming. Now in Tunisia, this more permanent Commotion installation was built in the town of Sayada. And this was done over the course of a 4-day workshop spanning 2 weekends in December of 2013. So here's the backbone. It covers about 70% or so of a town of about 12 to 15,000 residents. And think about that for a moment. 2 weekends, 70% of a town of 10 to 12,000 people covered with this technology. And since Commotion is also this intranet, the Sayada network contained everything from a civic portal for the local community's government to local copies of Wikipedia in French and in Arabic, an electronic book library that had about 2,500 titles, local maps, chat rooms, collaborative tools, even a local streaming radio station was put up soon after. So today, this is what Commotion does right now. You can download it right now and do this, right? Interconnecting users, sharing bandwidth, creating this open platform, dramatically lowering the cost of connectivity. All of the equipment that we use to create the Sayada network cost about $2,500. That's it. So when you think about the labor costs associated with 4 days of work, $2,500, bringing free local connectivity, sharing communications with a town of that size, that is doable right now, today. Now, what's next? So this is where XLab comes in. So since I've never been one to rest on my laurels, and since I seem to like making labs, I wanted to create this organization that was the nexus for building new ways to use Commotion, but also one that explores new territory in technology and policy. So the one that I like to start with, which I feel is the really scary, especially if you imagine this gulf of ignorance, right? Imagine this gulf of ignorance where people don't understand technological reality. Multiply that 100-fold and you get generals. Generals still believe that you can win a cyber war, and you cannot. But also spanning things like distributed production. And in DC, everyone worries about guns, 3D printed guns. This is the big thing, I'm sure, with terrorism on people's mind here in India. Probably it's something that people talk about here. The really disruptive element of 3D printing is when you solve, there's a material sciences problem of solving the tensile strength of 3D printed materials. But if you solve that problem, you can manufacture in a distributed manner things like car parts. And when you actually game out what that means, it disrupts not just retail, but trucking and shipping and manufacturing. Entire sectors of the economy get disrupted once that material sciences problem is solved. And that material sciences problem will probably be solved in the next 5 to 10 years. This reality is not talked about almost ever amongst key decision makers, even though it will certainly affect millions of people's lives. And of course, smart infrastructure, intelligent transportation. The Google driverless car is what everyone in DC talks about all the time. We will never see the Google driverless car, and I could tell a quick story to explain that. The Google driverless car cannot break the law. And the reason for that is, let's say the Google driverless car does break the law and runs over a kid. And the parents sue Google because Google is rich. And the judge asks Google, did you program your car to break the law? Well, obviously, Google can never be in a position to have to say yes. So they will build law-abiding driverless cars. Now, the question I have for all of you is, can you drive in Bangalore rush hour traffic without breaking the law? Obviously not. And so a Google driverless car cannot exist because there's a problem, which is that before everyone gets a Google driverless car, you have this period of time where you have driverless cars and stupid humans sharing the road together. And so we will never see the Google driverless car until these problems are solved. And they are political, and they're tort reform, and they're anything but technological. But they are very real. And of course, Privware, everyone talks about the Internet of Things. And in a world where all the widgets and gadgets of our lives, the things we interact with, we wear, we put onto, and eventually into our bodies, are capable of collecting an ever-increasing array of information about the most intimate activities that we are engaged in. Consumer protections, privacy protections are desperately needed. And without these consumer protections or general rules of the road, the future of a panoptic Internet of Things is incredibly grim. It's a future whereby you will all be discriminated against in ways that you have no idea are actually happening, and you will have no mechanism to correct those mistakes or address that discrimination. Into Circumvention Tech Lab. Today what you have are people that do things like needs assessment, people that develop the technologies, people that audit the technologies, people that distribute the technologies, people that do legal defense of those who use the technologies, all in different silos. It's remarkably inefficient, but it can be solved, and it's one of the things that we're looking at. How do we integrate this into a circumvention tech ecosystem? And finally, this brings us full circle to Commotion. So what's next for Commotion? Because as disruptive as everything that I've talked about has been, I think we're actually just at the tip of the iceberg. What the real commotion is going to come from what we do next. So imagine if Commotion is not just Wi-Fi. Right? Commotion is actually frequency agnostic. So what happens if we run it on other bands that aren't Wi-Fi? Right? And I see television white space as the shot across the bow. Right? Imagine liberating all these unused television frequencies, creating unlicensed cellular systems, integrating those cellular systems with Commotion so that dumb phones that don't have any Commotion software on it can still participate in free communications, free phone calls, free text messaging, etc. Imagine if we made use of the 90+% of spectrum that currently lies unused. One of the great lies is that we think about spectrum as full, but when you actually analyze spectrum use almost anywhere on the planet, you find that actual utilization rates are under 10% almost everywhere. The highest utilization rate that was recorded by the National Science Foundation was in New York City during the time it was George W. Bush's visit there, so all of the security, blah, 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 frequencies were in use, and that was 18%. So imagine if we use that in an efficient manner, opportunistic spectrum access, et cetera. And when I look at what's happening with software-defined radios, with cognitive radio technologies, I'm reminded of just how large the gulf is between 20th century spectrum regulation and on-the-ground technological reality. And what the dominant telecom companies don't seem to realize, or maybe they realize all too well, is how these technologies that are coming very rapidly, could build alternative infrastructure that either could be a graceful transition that complements their infrastructure, or a far more disruptive intervention, right? I talk about electromagnetic jaywalking on an international level that could happen here. So I think that Commotion plus these open stacks, the software-defined radio, the surveilles, the open BTS, the Osmo comms, all of that would be extremely exciting. One of the things that we funded was this group, Fairwaves, out of Russia. They developed a open hardware system. It's Creative Commons licensed. Anyone can buy it today. And so for about $1,500 right now today, you can build your own cell tower. And that's pretty cool, right? Like anyone could be a cellular provider for about $1,500. That would be really neat. And integrating all that would be extremely exciting, particularly for providing low-cost communications, especially in areas that are under or unserved right now today. And if you have this next generation network, then obviously it makes sense to kind of add in all of these privacy protecting technologies that should be a part of our communication system to begin with, but aren't currently. So integrating many of these circumvention services, these applications for people around the globe would have profound implications to protect ourselves from discrimination and data collection in the panoptic environment that otherwise is going to be happening. So our goal is not just about preventing harm. It's to realize the liberatory potential for new technologies, for digital communications writ large, to dramatically enhance community empowerment. And this year I began, or I guess last year now, I began collaborating with two groups, one called Loomio and the second called DemocracyOS, to begin generating sort of a next generation democracy platform. So this is Loomio, and Loomio was co-founded by XLab fellow Ben Knight, and it's a shared decision-making platform. Right? It's a way for people to discuss proposals, to collaborate, to self-organize. And Loomio, like Commotion, has already been proofed out. So as a quick Google search will show you, it's on the rapid ascendancy. It's got hundreds of thousands of groups already set up. It's got over 1 million users right now today. It's actually one of the technologies behind the Podemos movement in Spain, for example. And the second technology, DemocracyOS, is co-founded by XLab fellow Pia Mancini. And she just gave this great talk at TED, I guess now about 2-3 months ago. It's been seen by over 800,000 people, talking about why a distributed digital voting platform would be transformative to democracy. And in a nutshell, DemocracyOS allows direct and proxy voting on any issue or proposal. So it creates a system for direct elections, for direct democracy, and it's already in use in about 8 countries right now today. At the heart, this is really what XLab is about, right? We want to provide both connectivity and the digital resources to people to actually self-organize. We want to create a protection for the integrity of people's communications. We want to integrate discussion and decision-making tools. We want to close both the digital divide and this gulf of ignorance that really is holding us back, both of which, the digital divide and this gulf of ignorance, plague contemporary civil society. So fundamentally, Commotion is this free, open source software platform. It helps build community by interconnecting people directly to one another. And it uses the wireless devices that we already have. It integrates all of these tools, the ones that we know about today, the ones that people are still to dream up when they think about large-scale, free local communication systems becoming normative. And this is whether it's in your living room or your favorite cafe, or within your neighborhood, across an entire city, eventually throughout an entire region, and potentially, certainly, around the globe. And this, of course, can extend itself indefinitely. So I see Commotion's applications as limited only by our imaginations. And for me, this work has been a real labor of love, right? It's been an adventure that's introduced me to dreamers and idealists, optimists, visionaries. It's been surrounded by people all around the globe who have kept to these ideals, who have never allowed pragmatics and compromises to curtail their efforts, and have always stayed true to wanting to create a better world through the work that they do day in and day out. So with that, here's my contact information, and I hope some of you will be interested in collaborating. And in the interim, I very much look forward to answering your questions. Thank you very much.
Thank you very much. I wanted to do a little bit of marketing effectively. Sascha would be participating in the panel discussion this afternoon. And you have seen what he's thinking about. It is something similar to what I've been thinking about.
Hooray!
And the discussions we are going to hold is the 3 pillars driving all this, which are the standards. He talked about the regulation, which is 20 years behind, and in India it's even worse. And the next battle is IP. The question which I wanted to ask him was, how do you see this being used in India? Especially in the rural areas where 80% of Indians live, and in some places the challenge is there is not even electricity.
Yes, great question. And the reality is it's actually already in use in India. We had a training workshop in Dharamsala, I guess now about a year and a half ago, that brought together a couple dozen people that were doing community wireless work in India, as well as a number of ISP providers who are now integrating Commotion into their business models. Everything that I've laid out is completely business model neutral. So it's being used right now by people that are provide an even lower cost solution that they can fully control to bring low cost connectivity to areas that currently aren't served. And I see that clearly being something that India needs in spades. Right? I got to learn about how telephony was spread to a lot of rural India, and I feel like that same kind of intervention needs to happen in the broadband space. And these, I don't know if Commotion's not a silver bullet, right? I'm not trying to say this is going to solve all your problems, but certainly technologies like this, and in many use cases, Commotion itself is going to be useful in doing that. And one of the things that I've always loved about India is that, for my entire time in the community wireless space, in the mesh wireless networking space, there's always been a thriving community of experts here. And I feel like, it'd be great to, instead of always gathering information from folks here, to actually be able to provide some useful resource for people to use in their own backyards.
In the US, you've had failures of Muni Wi-Fi's in the bigger cities. I mean, they exist in several smaller deployments. So could you comment? I mean, was that partly technical, partly regulatory policy, partly business models? Or, so why did Philadelphia, for example, start and then, drop their Muni Wi-Fi?
Yeah, so Philadelphia, I will use that as a great jumping point for this, because I feel like it's a great example. The failure of municipal wireless is a giant propaganda campaign. So down in the lower end there is something called the Philadelphia Story, Learning from Municipal Wireless Pioneer, that I edited for full disclosure. But it tells the actual story of what happened in Philadelphia. Philadelphia, first and foremost, was not actually a municipal network. It was run by Earthlink, a major telco corporation. And if you look at Houston, if you look at Chicago, if you look at almost San Francisco, almost every single municipal wireless failure, almost all of them were not municipal wireless networks. They were owned and operated by telcos that definitely screwed up, but then sold a bill of goods to the general populace. It's pure propaganda. And I'm not saying that these problems were not difficult. We ran into so many cul-de-sacs during 15 years of development where we realized the solution we thought was going to work wasn't. In many cases, we simply didn't have things like the processing power on devices to really do what we wanted to do. But 2 years later, the technology went through another iteration, and all of a sudden that was no longer a limiter. And so, in terms of scalability, and in terms of the viability of these technologies, I would say what we know is really the stories that are told by telcos that don't want us to know about the efficacy of these technologies in the first place. And it does place a bit more onus on us to kind of peek below the dominant narrative. But certainly you see success stories all around the globe now of municipal wireless, of community wireless. You know, there's probably tens of thousands of community wireless networks all around the globe, spanning from very modest, small-scale ones to metro scale and larger in places like Vienna, Berlin, Athens, all over the place.